will be put into a low-level sleep mode, which means that if you wanted this car to last forever on batteries, as long as you're not using it, you could program the software to have it sleep, and then you wouldn't be wasting batteries if you forget to turn the switch off. And it says it has a 900 nanoamp power down mode. That's pretty small. It has 4 power outputs selectable by the user of 0, -6, -12, and -18 dBm. For this project, I went kind of with the 0 power. I wanted to, give it the most power I could. I wasn't sure what it was going to do, so I wanted to use that power. And then finally, the kind of key to the whole wireless transceiver is this data array called payload. And payload can be anywhere in size from 1 to 32 bytes. And this has been the key to my whole project, is getting this figured out. On the transmitter side, there is some initial code that you set up, but basically you start with the joystick, and I created a component in Processor Expert that was a to D converter, which would read the values of the joystick, and it would return a 16-bit left justified number. So the A to D converter was, it worked with a 12-bit conversion, and because I was using 16-bit left justified, because that's how big I set my payload array, I was essentially taking the 12 bits and shifting them all to the left and filling up the upper end of the array there, I guess you could say. So I had to break the 16-bit numbers into smaller bytes because of that. So I basically had 4 arrays in payload. The first 2 were for the vertical movements, and the reason why there are 2 is, like I said, I had to break them down, and then there were 2 for the horizontal movements. And then it just took payload and it transmitted. So then the receivers, so here's a kind of a breakdown of what the actual chip looks like and the signal lines. The only thing I didn't mention was that the SPI communication used the first 4 signal lines, and then this wireless chip added 2 more. It adds the CE line and the IRQ line. The CE line is like slave select, where it basically turns the transmitter on, or the transceiver on, and lets it know whether it needs to be listening, receiving, or talking, or transmitting. So, like the CSN line that activates the slave so it understands that it's time to receive data, the CE line does that with the transmitter for the RF side, not the SPI side. And then there is an IRQ pin, which is an interrupt that basically allows the software to know when data has been sent or received. So, when the receiver receives information, it sets a flag, it acknowledges back to the transmitter that it's received the information, and then it sits there and waits for the transmitter to send more information. This is a kind of the beginning of my software. Because the software is essentially the same on both the transmitter and receiver, I had to find a way to let it know if it was a transmitter or receiver. So on the transmitter side, I gave it a value of 1, and on the receiver side, it has a value of 0. Then you have the payload size, and I have it set for 16, although I probably could have gotten away with something smaller like 4, since I really only used 4 separate arrays for my data. And then finally, I had the ability to select which channel number I had, and I chose 50 because that seemed to work for me. Here are two pictures of waveforms that I took from the oscilloscope. The top pulse, the yellow, is the transmit side, and the blue line is the receive side. So here you can see the 16 different bytes in the transmitter payload, and the whole group of 16 bytes took 30 milliseconds to transmit. And then on the receive side, this is what it received, and it was about, I don't know, about 10 milliseconds worth of data. And really, it was practically only a millisecond or less time between the time that it transmit from the transmitter to the time the receiver got it. And I put these two red blocks here so you can see that if you physically took this and lined it up over that, you would see that they're essentially the same thing. The bottom picture is the same idea, except I held the joystick in the forward direction. And you can see here how it changed the bits and stored the information there. And if you compare it to this one, you can see that it obviously did something a little bit different there. Here's a little bit of the software. I had the joystick get value 16. That's where I took the A to D conversion reading and stored it into an array called data, and then took each of the data arrays and separated those to be put into my 4 different payload arrays. So payloads 0 and 1 are my vertical movements, and payload 2 and 3 are my horizontal movements. And then once that was completed, I had payload in this command called RFTX payload, and that was what essentially sent it out to the receiver. On the receive side, I have basically just the receiver receiving the payload. And it wasn't anything harder than taking the received payload and breaking it back out into two variables that I called vertical, or vert and hors, for vertical and horizontal. I guess I realized after doing all those conversions that I just took the first array of each movement, vertical and horizontal, and used those numbers. And so I went from a 12-bit number to like a 8-bit number, I guess. On the receive side, I start with this line of code at the top that basically finds the status and receives the payload. And then it resets the flag, the reset status IRQ. And then I just take my payload and I put it into vertical and horizontal. And then finally, this was kind of the code that we used last semester in the wired RoboCar, but when vertical and horizontal are greater and less than a value, and horizontal is also greater than and less than, it doesn't move, so that means the joystick's sitting in the middle. And then depending on which way you're moving the joystick, it moves forward or backwards and left and right. Thank you. Any questions? Now, here's my finished product. You see that on the... maybe I shouldn't have put the car body on it, but essentially I went to the thrift shop, got this really fancy car body, and attached it to really give it that Walmart look. but I can actually demo to you what I have so far. It's still a work in progress. You want to move the camera down to the table?
And does it work the same way as the wire?